Good day, my name is Dr. Lucas du Plessis. I'm a senior lecturer in the Department of Mechanical and Aeronautical Engineering at the University of Pretoria, and I would like to just take a few minutes to tell you more about the Shigley Hauler project, which is a project that I want to initiate for the second year mechanical and industrial engineering students taking the module Manufacturing and Design with the module code MOW217. What you can also see on the screen here is my contact details, my email, as well as my mobile phone number, so you are very welcome to contact me should you require any additional information. So on this screen you see the Shigley Hauler gearbox as I envisage it. I would like to I'll come back to this screen. I first would just like to tell you a little bit more about where the project originated from. So in 2016 there was a research paper published by the University of California in Davis by Rida Faruqi and Barbara Link. I hope I pronounced their names correctly. Apologies if I don't. But anyway, they wrote, or they initiated, a Shigley Hauler competition at the University of California, Davis. Now, if I can just scroll down, I'm not going to read the whole paper here, so don't worry about that. So first the name Shigley, where does that come from? So Shigley's Mechanical Engineering Design is a textbook that has been in publication, I think it's since 1965 roughly, when the original manuscript was published. It is really an academic standard. It's used in many universities. At the University of Pretoria, this textbook is prescribed in no less than 5 undergraduate modules for the mechanical and aeronautical engineering curriculum. One of the modules is at the University of Pretoria is this MOW217, which I teach, and as I said before, it's for second year mechanical and industrial engineering students. So anyway, this is really the standard in an academic or from an academic perspective on the topic of mechanical engineering design. Alright, so what you see on the screen is a photograph of what the textbook actually weighs, and this is now was measured in the US, so it's 4 pounds and 4.5 ounces, which equates to just less than 2 kilograms. And this is now for the hardbound or hardcover textbook that you see on the screen. So in South Africa, I haven't seen the hardcover used here. The soft cover is more general, but be that as it may, the content of the textbook is obviously the same. So that's the name. It's a Shigley Hauler. So the hauler is for a gearbox that the students at the University of California designs and manufactures. Now they have a small group of students and they work in teams. They also have a well-equipped workshop. So each team or each group of students get issued with this kit consisting of a small electric motor and a set of plastic gears. And they then, as I said before, they then have to design and manufacture and assemble a gearbox. Now, if I can just scroll down a little bit, I'll show you a photograph of what the gearbox, or one of the gearboxes, what it looks like. So there you can see, there's the electric motor, the gears, everything is assembled inside a frame. From this photograph, it's unclear if the students used ball bearings or sliding bearings, but be that as it may, the gears are fixed to the shafts. And what you see here is a small pulley with a fishing line, okay? And also, so this is the Shigley Hauler. This is the gearbox that is then attached to a ramp, a wooden ramp. You can see the top part of the wooden ramp in this photograph. there's, if I can just scroll back up again, there's a schematic of what the wooden frame looks like. Here it is. So it's roughly 1 meter long, 12 inches. I think that's about 360 millimeters, roughly wide, and there are 4 tracks on this wooden ramp. And the wooden ramp can be inclined at different angles. Okay, so just going back to that photograph, so the groups of students then compete on the competition day. They will attach their gearboxes at the top of the ramp, and the ramp then gets inclined at different angles. At the bottom of the ramp, there's a trolley or a cart that the students also design and manufacture. And then the Shigley textbooks are then stacked on top of this cart, and it's attached to the fishing line. The gearbox is here at the top of the ramp. It's not shown in this photograph. The lecturer has a stopwatch, and then these teams compete in terms of time it takes to pull up the Shigley or the trolley with the stacked Shigleys. Okay, so at the University of California at Davis, they have these sub competitions. So it will what this means is there's one Shigley and the ramp is inclined at 20 degrees, and then they will measure the times of the different teams. Then they stack 2 Shigleys and incline the ramp at 30 degrees. Do the same, measure the times. Then 4 Shigleys at 40 degrees. And lastly 5 Shigleys on the trolley at an angle of 60 degrees. And these teams with no entry, they obviously their gearbox did not manage to pull up the load up the ramp. So at the University of Pretoria, our class sizes are much bigger than at the University of California at Davis. This year, in 2023, we've got 340 students in the manufacturing and design class. Last year, there were 400 students approximately. It was either 399 or 400, I can't remember. So although the University of Pretoria and the Department of Mechanical Engineering does have a well-equipped workshop, it is impractical to, even if you divide the class in group sizes of 10, it's impractical for 34 groups to manufacture, design and manufacture a gearbox of the Shigley hauler. Because those students, even for 34, those students will have to be trained on how to use the equipment. There are health and safety risks associated, so on. So from a practicality point of view, it wouldn't work to expect a second year student to design and manufacture and assemble a gearbox. So my idea is slightly different. What I want to do is I want to issue each and every student with a pre-manufactured kit consisting of all the parts needed to assemble a Shigley hauler gearbox. And that is what you see on the screen here. This is what I envisage that the gearbox will look like. Also, the reason why I want to issue each and every student with such a kit is it will instill and illustrate all the aspects of the module, the theoretical aspects of the module, manufacturing and design, to the students. They will have something in their hands that they assemble, and it will really ground the theoretical aspects of the module very well. So I'm quite excited about that. What I see when grading students' practicum tests and exams, etc., is there's a lack of physical appreciation, if I can put it like that, for the mechanical components and devices that they are designing. And this project, that's why I'm so excited about it, this project will bridge the gap from looking at nice pictures on the screen or in a textbook, from physically touching and assembling something. It will really ground all the principles, and I think the project will play a huge role in cultivating an appreciation for mechanical design. Okay, so with that said, I definitely want each and every student to have a kit. That's the end goal. Maybe in year one, we can work in very small groups of 2 students each, but the long-term plan, the long-term goal is definitely to issue each and every student a kit. Okay, so how the Shigley Holler competition will then work at the University of Pretoria is at the beginning of the semester, each student will be handed a kit and they will assemble the gearboxes, and towards the end of the semester, the students will bring their gearboxes, and we will not have a single wooden frame. We will have a slightly more refined frame made from aluminium extrusion, for example. It will be a bit more refined, and there will be between 10 and 20 of these identical frames. Each frame will be able to accommodate 4 gearboxes and trolleys. So if we have 10 frames with 4 tracks each, we can test 40 gearboxes simultaneously. If we have 20 frames with 4 tracks each, we can test 80 gearboxes simultaneously. On the competition day, all 340 students will bring their assembled gearboxes. They will be allowed to invite parents or friends. And I'm going to invite the whole of the mechanical engineering department, all students plus guests, people from industry who may be interested to visit. I'll invite all of them, and we will have the competition at the University of Pretoria Sports Centre. And what you see on this, this is an aerial view of the sports centre. So it's a huge facility, and what it looks like on the inside, there you can see there are seats right around. This just shows a few of the seats in the pavilion, and then there's a huge area. This was now set up for netball, it seems. So all these setups can be removed, and so we'll have the 10 or 20 frames with 4 tracks each set up here in the middle, and I'll have teaching assistants helping me. So the students will bring their gearboxes, either 40 at a time or 80 at a time, connected to the frame, pull up their trolley with a Shigley textbook on top of it, and the time will be recorded. So what I also envisage for the University of Pretoria competition is not to incline the ramp at different angles. I don't think that's really necessary, because all the gearboxes will be exactly replicas of each other. I'm not seeing any value in having different inclines, etc. So it will be a single incline, typically 50 degrees, and there will be a Shigley textbook, a single Shigley textbook on the trolley. They'll bring their gearboxes and pull up the Shigley on the trolley against the ramp until it reaches the top. And then obviously we can identify the best student, and this will now be dependent on assembly finesse, if you like. But it's really not about winning the competition. It's more about getting the exposure of assembling the gearbox, for a student to assemble the gearbox, bring it and connect it to the test or to the frame, and switching the gearbox on and seeing how it pulls up successfully this trolley with a single shigley. I think that's the accomplishment that we want to achieve, apart from the fact that they will have a very sound understanding and appreciation of mechanical design. So what I would like to just end my video with is just a brief explanation of what the gearbox looks like. So it also consists of a small electric motor. It is connected to a shaft. I'm proud about this connection. It's actually a Dremel tool collet that clamps onto the motor shaft, and then this is the drive shaft. Okay, if I can just show you, there's a, yes, so there you can see the pinion gear on the shaft, and this then drives a larger gear on the second shaft. There's another pinion gear on the second shaft which drives the third gear, and then I don't have a pulley on the final shaft, but there's a hole through the shaft, and there's this deflector plate to just guide the fishing line as it winds onto this shaft. Okay, and what I have there at the end, there's a slot then in this aluminium profile for the fishing line to go through and lead or connect to the trolley at the bottom of the ramp. Okay, so the rest of the design, maybe if I can just say what I've also designed here. This is my personal design that I did. So for each of the shafts, I use deep groove ball bearings, and I have on the one side a locating arrangement, and on the other side a floating arrangement. So that's all designed in, and the frame of the shigley hauler gearbox is made up of aluminium profile, and the sides and all these flanges, those flanges are made from polycarbonate. So it's also a nice effect for the students to actually see through the gearbox as it rotates, and I think it will be a nice effect. This top cover plate is also made from polycarbonate, so everything is see-through. So this flange onto which the motor is mounted, I'm thinking of using a harder plastic or possibly an aluminium, depending on the availability and the cost, etc. But that's the idea there. The rest of the assembly, so what I can maybe just say, also I've made provision for alignment of the two side plates, and that's done with these dowels. So the dowels run through the base profile on the bottom, and there's a slot on one side. If I can show you, there's a slot here, and on the other side or other end there's a hole. So those two dowels run all the way through, and they ensure good alignment between the two side plates. Okay, so when you bolt the side plates on both sides, because of those dowels, there's good alignment. Just lastly, to end off with, so I'm approaching different companies for sponsorships, and there is some interest. So I'm really excited about the prospects of this competition. Obviously, what's in it for the sponsors? On the day of the competition, there'll be in this sports center there will be an opportunity for you to set up a display, and you will have airtime. You will have airtime to say a few words about your company and why it is a great place to work for. So as I said, I'm going to invite the whole department, all undergraduate students, and plus their parents, friends, everybody's going to be there. I'm envisaging a big event. It will be typically a 3-hour event, which corresponds to one of the time slot allowed for one of the practicums in MOW 217. As I said, it will be towards the end of the semester. So students will come, we'll do the testing of the gearboxes, there will be a prize giving, and any sponsors will have airtime to say a few words. Plus you will have the opportunity to have a display unit or a stall where you can display some of your products, and students can move around between the stalls, etc. The last thing that I just want to say is, so the sponsorship, we need an initial, a once-off sponsorship to manufacture, and for in a conservative estimate, what I was thinking is to manufacture 450 kits of this gearbox. So, but that's a once-off investment that you will make. We will issue the students with the kits, as I said, at the beginning of the semester. Towards the end of the semester, each student brings his or her assembled gearbox that gets tested, and after testing, the gearbox gets handed in. I take the gearbox back, I dismantle all the parts, I inspect and replace where necessary if something got damaged, and the following year the same kit gets issued again. So it's a once-off investment, although the competition is going to be an annual competition, and you will have airtime at each and every competition day for the duration of while I'm teaching at the University of Pretoria. This competition is going to be an annual event, and so for as long as that happens, you will have an annual airtime opportunity to display your company, to advertise your company as a workplace, and display their products. So I think it's a great win-win opportunity for everybody involved. And with that, thank you very much. As I said, if there are any questions, you are most welcome to contact me. My email address and cell phone number are displayed on the screen, so I very much look forward to hearing from you. Thank you.